Good morning, student. I hope you are safe and healthy. Yesterday, in previous class, we already started this basic concept in geometry, and different concept we already learned. Now, when we learn the different concept in geometry, some statements we have to prove. Now, according to the postulates, by using that postulate, what is postulate? Postulate means these statements which are already proved, that is logically already proved, or some students are some postulates are there, they are proved by different activities by different persons. So by using these postulates, you have to prove these statements. Now statements also, there are two types of statements, a simple statements and other is called as conditional statement. Now what are the statements? See, here one statement I have given the example here. So statement, what is the statement? The diagonals of a rhombus are perpendicular bisector of each other. This is the statement of geometry. Okay, the diagonals of a rhombus, if the quadrilateral is rhombus, the diagonals of that rhombus are always perpendicular bisector of each other. This is the geometric concept, this is the geometric postulate, and now you have to prove this postulate. Okay, now there are two types of statement I already told you. This is the simple statement, the diagonals of rhombus are perpendicular bisector of each other. Now what is the conditional statement? Now when we apply any condition to this simple statement, that statement is called as conditional statement. Now how you apply the conditions here? See here, the diagonals of a rhombus are perpendicular bisector of each other. This statement will written as conditional statement as, see, if we add the condition here, if the given quadrilateral is a rhombus, then means you add if and then. When you add if and then it is a conditional statement. This is simple statement and you add if and then in this simple statement, then it is called as conditional statement. Now the statement is, if the given quadrilateral is rhombus, if it is rhombus, then and then only its diagonals are perpendicular bisector of each other. This is the condition. So this statement is called as conditional. This is simple statement and this is conditional statement. Now here, after if the given quadrilateral is a rhombus, this part is called as antecedent of a statement. This part is called as antecedent of the statement, and after then its diagonals are perpendicular bisector of each other. This part of the statement is called as consequent. Means in a conditional statement or in any statement, there are two parts. One is called as antecedent and other is called as consequent. Means the part after if is called as antecedent and the part after then is called as consequent. Means there are two types, two parts of any condition. There are two parts. One is antecedent, other is consequent. Now simply see here, when we write the statement, there are two parts. One is the part after the if and the part after then. Means in any condition, the two parts are there. One is called as antecedent, other is called as consequent. Okay. Now this is a conditional statement. Now sometime we converse this statement. Now what is the converse of the statement? If you interchange the antecedent to the consequent and consequent to the antecedent, then it is called as converse statement. Means after if the statement, the part of the statement after if is added to after then, and the part of the statement after then is added to if, then it is converse statement. For example, see how you write this converse of this statement. See here, if the diagonals of quadrilateral bisect each other, then the quadrilateral is rhombus. Means here The antecedent is the diagonal of a quadrilateral bisect each other, and the consequent is the quadrilateral is rhombus. This is the consequent, but here it is the quadrilateral is a rhombus. This is antecedent and its diagonals are perpendicular bisector of each other. This is the consequent. When you change the antecedent and consequent, then that statement is called as converse of the given statement. This is the given statement and this is converse of the given statement. And there are two parts. One is antecedent, other is consequent. You interchange the consequent and antecedent, then the statement is said to be converse of the given statement. Now, so you have to prove the given statement logically by using the postulate. When we prove any property, geometric property, by using logical concept, then this proof is called as theorem. This proof is called as theorem. Means you have to prove any statement logically by using the postulates, then that proof is called as theorems. Now in theorem, again when we prove any statement, means any theorem, then you have the statement first, that is you have the antecedent, you have the consequent, and then you have to prove. Now this part, antecedent part in any statement is said to be a given. This is the given part, and this is said to be to prove. Means given is antecedent and consequent is to prove, and then you have to take a proof by using the proved activities, or using the postulate logically, and then you can prove this statement. So this is called as theorem. Now in 9th standard, you have to prove a different statement or different theorems, and by proof that theorem, you have to use that proof to different sums to solve the sums. So this is called as theorem. Okay. Now after this, again we prove any statement or any theorem by two types. One is called as direct proof and other is called as indirect proof. Sometimes you can prove by direct method or logical postulate method, and sometimes you can prove indirectly the given statement. So again we can prove the statement by two types. One is direct method or indirect method. Okay, now we have to go to one example how to prove the given statement, how to prove the theorem, given theorem. Now in next we have to go the example. Dear student, now we have to see this example, how to we can prove the statement logically. This is direct statement, direct proof. The statement is yes, the given statement of the theorem is the opposite angles made by two intersecting lines are congruent. Now when two lines are intersecting each other, then the angle made by these two lines, the opposite angle made by these two lines are always congruent. This is the statement. Now you have to prove this statement logically. Okay. Now in this statement, I already told you there are two parts. One is called as antecedent, other is called as consequent. Antecedent means that is given. Antecedent means that is given, and consequent means to prove. What to prove? Okay, there are two parts. So first you have to write down here, when you are going to prove any theorem or any statement, then you have to write down the given here. So given is line AB intersect line CD at point O. This is your given. So this line AB and line CD, they are intersecting at point O. So this is the given, this is called as antecedent. Now what to prove? to prove angle AOC is congruent to angle BOD. These two angles are opposite angles, vertically opposite angles. These two, you have to prove these two angles are congruent or these two angles are congruent. So first we prove AOC is congruent to BOD. Now how to prove? Then the step is proof. Third step is proof. Now in this proof you have to write the statement logically correct. Now what is the statement? See here, angle AOC, this is the angle. Now second angle is COB, this is COB, these two angles. When we add these two angles, it is a linear pair. Means if we add these two, you get the 180 measure, because this is a linear pair. Okay, we already know what is the linear pair. These two angles are formed linear pair. It means AOC plus COB is equal to always 180. This is a statement 1. This is logically proved, because angles of a straight line is always 180. Means this angle is straight line angle and these two angles are said to be linear pair. The linear pair having 180 measure. So this is the logical statement 1. Now come to second statement. Now what is second statement? Again see, BOD, this angle, and this COB, this angle. These two angles are also the linear pair, because this is a straight line angle and straight line angle is always 180. So BOD plus COB is equal to 180. So this is also logical statement. So it is statement number 2. Now see these two statements. First statement having the right hand side 180 and second statement is also having the right hand side 180. Means the right hand side of both the equation, both the statement having 180. If the right hand sides are equal, then left hand side also equal, because the equal to sign is there. So therefore these two sides are equal. It means the left hand sides are also equal. It means logically AOC plus COB is equal to BOD plus COB. See, AOC plus COB is equal to BOD plus COB from 1 and 2. The statement 1 and 2, we can say that these two sides are equal. If these two sides are equal, then see, when we eliminate, here COB is there, here also COB is there, both are equal. So you can cancel this or you can eliminate this. By eliminating angle COB, you get AOC is congruent to BOD. Angle AOC is congruent to angle BOD. This is proved. So see here, what to prove? AOC is congruent to BOD, and here you proved that AOC is congruent to BOD. In this way, by using the postulate, using the logical statements, you can prove any statement. You can prove any statement, any theorem, and then you can use this statement or this theorem to solve the examples, to solve the sums in a geometry. So this is called as direct proof. It is called as direct proof. Okay. So another proof is there, that is called as indirect proof. Now how to prove any geometric statement indirectly? Okay, indirectly how to prove? This is direct proof. Now sometime we can go to indirect proof to prove any statement. Okay, now we go to the next example in next lecture. So now we stop here.